This is the first example for topic number 5, solving 3x3 systems of linear equation, and in ALEKS this is called problem type number 1. So here I got 3 equations, and when I saw it, the first thing that I noticed was this. Did you guys also see that there is x and there is negative x? They're opposite. We found something already. So if I add, may I give them some names first of all? I'm going to call the first equation, equation 1, second equation, equation 2, and the bottom one, equation 3. So if I start using this parenthesis 1, 2, or 3, I'm talking about these guys, okay? So if you take a look at equation number 1 and equation number 2, they already have the opposite. So step number 1, I have a plan. I'm going to add equation 1 by equation number 2. Okay, I'll add those two together. And why do you think I'm doing that? I'm doing that because I noticed they are opposite terms, negative x and positive x. If you add them, they will cancel out. So I'm going to write down equation 1. This is equation 1. And I'm going to write down equation 2 right underneath it. And I will add these two together vertically, okay, by like terms. So what will happen? Oh, it doesn't have to be that long. It just has to be about this long. The negative x and positive x, this will cancel out, right? Next, if I add 3y plus negative 1y, that's going to give us 2y. Over to the z's, if I add z plus 2z, that is 3z, and this equals, add the right side, 3 plus 0 is 3. And we just created another equation, right? How about we call this equation number 4? Because we had 1, 2, and 3, we just came up with equation number 4. So keep this here because this is a good equation. This doesn't have x in it. So what I'm now going to do is, you notice how we never used equation 3 just yet? We're going to use equation number 3 to create an equation that is missing x, okay? As you can see, this equation number 4 is missing x. That's what I want to create. So if you look at the third equation, let's look at this. If I want the x gone, and you know exactly why we want the x gone, right? This fourth equation doesn't have x, so we want the x gone. If we want the x gone, I need negative 3x. Does that make sense? To cancel out positive 3x, we need negative 3x. When I looked up, I noticed that equation number 1 has negative x already. So if I multiply 3 to that negative x, wouldn't we get negative 3x? So that's the plan. That is the plan. Plan number 2, step number 2, is for me to, I'll go ahead and write it over here, okay? Multiply, oh, my U looks weird here. Multiply equation number 1 by 3 and add this equation number, that looks like add with equation number 3. So that is what I'm going to do, okay? So that's my plan. So let's go ahead and multiply 3 to equation number 1. If you do that, you get negative 3x plus 9y plus 3z equals 9, right? I just distributed this 3 to all these terms. That's what we do. Okay, now let's go ahead and write down equation number 3 in the bottom. Okay, in the bottom of this. 3x minus 5y plus 2z equals negative 2. And I'm going to add them together. I'm going to add them together because the x will cancel out. So take a look. If I add these two together, as you can see, as we planned for this moment, that negative 3x plus positive 3x is canceled out. No more x. That is perfect. I'm going to add the y's this time then. All right, hold on. If I add 9y plus negative 5y, that's going to give me 4y, right? Next, let's add 3z and 2z. Shh. That's going to be plus 5z, plus 5z, and that equals the right side of the equal sign. Stop it, Luna. 9 plus negative 2 is 7. And let's call this equation number 5. So we started with 3 equations. They gave us 3 equations. But we created 2 more, right? We created 2 more. And what is significant about these 2 equations that we just created? I'm going to go ahead and get rid of some of these highlights because we don't need to be looking at these right now. I'm going to go ahead and get rid of some of these highlights right now so that you can focus on what is important now. So look at 2y plus 3y 2y plus 3z equals 3, and this one 4y plus 5z equals 7. We're going to work with these 2 purple circled equations. Okay, if we use those 2, we should be able to find what y is and z is. So that's the big plan. Okay. Alrighty, I'm probably gonna want to use another sheet of paper for this because I want to write all my work in an organized way. So let me go ahead and move example number 1 to the other page for the next problem. So I put a sticky over that problem so that I can write over it. So let's work with equation 4 and 5, the ones that I circled in purple. Okay, so I'm gonna write, now before I write them on top of each other, we should try to eliminate another variable. Now, did you see that there is 2y, and there is 4y, okay? If I multiply equation number 4 by negative 2, wouldn't I be able to make its opposite? So take a look. Here's my plan. I'm going to, step number 3, multiply equation 4 by negative 2. And you'll see why I'm doing that, okay? I'm going to go ahead and write negative 2 over here next to it so that you can see. If I do that, I will get negative 4y, okay? But negative 2 gets multiplied to all the terms here. So next term will be minus 6z, and that equals negative 6. Okay, that's good. And that was equation number 4, who got multiplied by negative 2, right? And then I'm going to go ahead and add this 2 and add with equation number 5. That's my plan. So I'm going to write down this equation number 5 underneath here, okay? And I'm talking about this one, that one. So 4y, write down 4y plus 5z equals 7. Okay, that's the plan. And I'm going to now add them. Okay. And why was I doing all this? Because you'll see now, you'll see. Okay. As you can see, this negative 4y and positive 4y, they cancel out. Yay, we eliminated it. But if I add, here you go, negative 6z plus 5z, wouldn't that give us negative 1z, right? Negative z. And that equals adding negative 6 plus 7, That is the same thing as 7 minus 6, so that's 1. So what does that tell me? If I divide both sides by -1, okay, I'll go ahead and write that down, why not? If I divide both sides by -1, we just found what z is. Z is -1, and I'm gonna circle it, yay. So we found one answer so far. Now let's find what y is. Oh goodness. I'm gonna go ahead and plug. Alright, 1 second. I just need any equation that has y and z. Doesn't have the third variable x. I can use any of these, but hey, maybe I can just use, I'll use number 4 from above here. Okay, I'll just use this one of the purple circled one. It really doesn't matter what you do, what you pick, as long as it has y and z. So I'll plug it into, here's my plan. I like to write down my plan. Plug in c equals -1 into equation 4. Okay, and equation 4 was 2y plus 3z equals 3. And you could have easily went with this one or this one. Doesn't matter as long as it only has y and z. Okay, let me go ahead and do my substitution. 2y plus 3 times -1, that's what z is. This equals 0. And the reason we're plugging in z equals -1 is because we want to and solve for y. We're trying to solve for y here. If you take a look, I'll get 2y minus 3 equals 3. Add 3 to both sides, we'll get 2y equals 6. Divide both sides by 2. Y came out to be 3. This is awesome. So we solved it. So hold on, this is, maybe I wrote too big because it looks like I'm going to need to find another piece of paper, which is okay. These problems are a little bit longer. So I'll go ahead and get another piece of paper because we're almost done. We have y and z. I just need to find what x is, right? So how about I add another piece of paper over here? Give me 1 second. I just like to take my time on these problems. So last step, step number 5, we're going to plug in what we have. We're going to plug in y equals 3 and z equals, what was it, -1, I believe, into one of the equation that has x, y, and z. Okay, so I'm going to go up and copy one. Here it was. And I guess everything else is okay, but I particularly like number 2 because it has x in it. So I'm going to use the second equation. I'm going to use this equation. And the reason is because it has just like a simple x in it, not -x or not positive 3x. So that's the only reason I am going to plug it into this equation. This is the equation. All right, so I'm ready to do my substitution. So x minus y is 3 plus 2 times -1. That equals 0. And I'm going to solve for x. This is x minus 3 minus 2 equals 0, which means x minus 5 equals 0. Now finally, x is what? 5. Yay, we solved it. So the solution is x equals 5, y equals 3, and z equals -1. You can write this as an order triple. You can do 5, 3, and -1. Since we have a unique solution, we get to say that this system is consistent, independent. with this single unique solution of 5, 3, -1. Okay, so this is how you can solve a 3 by 3 system using multiple elimination method.